Okay, pre-cal students, in this video we will be solving inverse trig problems. So go ahead and get out your notebooks. Let's take some really good notes today, and hopefully we can learn some new math. Here we go. Your heading for today is arcsine, arccosine, and arctangent. And the lesson number for today, I'm not sure why I did not include that, but the lesson number for today is 9.8, I believe. Actually, that's incorrect, 9.7, okay? So please copy down your heading, arcsine, arccosine, arctangent, lesson number 9.7, and be sure and include today's date so your notes are nice and organized, okay? All right, let's continue on. Now, let's start off by learning how to rewrite an arc expression. Students, if you can learn how to rewrite an arc expression, then it really makes the problems become a lot easier, because you'll see a problem like arcsine or arccosine or arctangent, and you'll learn to rewrite it in such a way that makes the problem easier to solve, okay? So here we go. Please take some really good notes on this. Arc cosine of square root of 2 over 2. Arc cosine of square root of 2 over 2 can be written as the following. This is so much easier. Look at this. Arc cosine of square root of 2 over 2 just means this right here. Look at that. It just means you're looking for an angle. So take some notes on this, okay? Square root of theta equals square root of 2 over 2. So when you look over here and you see arc cosine, that just means you're looking for this angle right here. Cosine of theta equals square root of 2 over 2. And of course, you know what this means right here because you've been typing this into your calculator now for months. Inverse cosine square root of 2 over 2, this means the same thing. Cosine of theta equals square root of 2 over 2. So when you see arc cosine, that just simply means you're looking for an angle. Or in other words, this entire expression right here just equals an angle. And the same thing with this. When you see inverse cosine or inverse sine or inverse tangent, it just means you're looking for an angle. Cosine of an angle equals square root of 2 over 2. Okay? All right, now let's continue on. With this in mind, let's try some numerous examples that will help us get used to the inverse trig functions. All right, here we go. Now, really nothing to copy down yet. This looks like it's a little bit messed up over here, but it's not. Okay, just sit tight and watch. You might want to draw a coordinate plane in your notes to help you. It's up to you. You should have this table somewhere in your notebook, in your notes somewhere, and it's good to use it. It saves us a lot of time. On tests and quizzes, you're not allowed to use this, but on homework, it does make the homework a little faster. Okay, so let's start off with our first problem here. Go ahead and copy this in your notes if you would, please. And there it is. Please copy that down, okay? Let's solve arc cosine of square root of 2 over 2. Now, first of all, let's rewrite it. Okay, take some good notes on this. Cosine of theta equals square root of 2 over 2. Now, students, remember from a previous video, whenever we're dealing with arc cosine, cosine deals with the first quadrant and the second quadrant. Whenever we're talking about arc cosine or inverse cosine always deals with the first and second quadrant, okay? So, we're trying to find an angle. Now, look at this carefully. Arc cosine of square root of 2 over 2 means cosine of theta equals square root of 2 over 2. Now notice the square root of 2 over 2 is positive. Okay, now because it's positive, that means we're going to be dealing in the first quadrant, because we know over here if we took cosine of theta we'd get a negative answer, because over here cosine is negative. So we know we're dealing in the first quadrant, and so now let's see what we have. When does cosine of an angle give you square root of 2 over 2? Well, here's cosine. Here it is right here, look. Right there. So cosine of 45 degrees, or pi over 4, is square root of 2 over 2. So there we go. We have the answer. In the first quadrant, we would go ahead and write 45 degrees, or pi over 4. Either one of those two would be acceptable, okay? And there we go. Okay, moving on. Let's go ahead and try another problem here. All right, arc cosine of negative 1. Please copy that in your notes. Arc cosine of negative 1. Now, let's first of all rewrite it. So cosine of theta equals negative 1, okay? Cosine of theta equals negative 1. Now, remember, cosine runs from 0 to 180, the first and second quadrants. Okay, so keep that in mind. Now, I'm going to go ahead and type in the cosine of 0 and the cosine of 90 and the cosine of 180 to see if I get out a -1. All right, so here we go. I'm going to make sure I'm in degrees real quick, and I am. And let me pause and say this. The reason I'm typing in 0, 90, and 180 is you look down here. Don't forget, students, remember, most of the time, whenever you're trying to find an angle and it gives you out 1 or 0 or undefined, not always, but most of the time it's going to be a quadrant angle or an axis angle. Okay, so in this case we're going to try 0, 90, and 180. So with my calculator I'm typing in cosine of 0 and I get out 1, so that's not it. Cosine of 90, that's not it. Cosine of 180, and that's it. There we go. So theta would equal 180 degrees. Or if I wanted you to write your answer in radians, you would put pi. Okay? Hopefully you're getting this. Let's move on. Okay? Let's try the next problem here. Okay, copy this in your notes if you would, please. Arctangent of 0. Arctangent of 0. So that we're going to first rewrite it. So we're going to say tangent of theta equals 0. Now, remember once again, usually when you're trying to find an angle, that when you take a trig function of that angle, you get 0, 1, or undefined. Usually it's going to be a quadrant or an axis angle. Okay, now, remember, tangent and sine are not first and second quadrant inverse functions. Okay, tangent and sine are first and fourth. Okay, and we've learned that in a previous video. So we know that tangent is going to go from 0 to 90, or from 0 going this direction to -90. So in other words, we're going to run your theta right here. Your theta is going to run from, let's see, greater than or equal to -90 and less than or equal to 90 degrees. Okay, so it's going to run from here to here. All right, so here we go. Let's go ahead and try 90 degrees. Tangent of 90 does not give me 0. Tangent of 0 gives me 0. That works. Let's also try tangent of -90 real quick. Tangent of -90, we get undefined. So the answer is 0. Tangent of 0 equals 0. So there's your answer. Okay. All right, let's continue on to the next one here. And let's see, what do we have next? This one here. All right, here we go. Arc sine -1/2. Very quickly, first thing I'm going to do is I'm going to rewrite it. Sine of theta equals -1/2. Okay, now remember, sine is restricted to quadrant 1 and quadrant 4. Okay, by definition of arc sine. Well, I want an angle so that when I take the sine of that angle I get -1/2. That's going to put me in this quadrant down here. Okay, now when does sine, I think I accidentally erased this here. That's not a good thing. Let's see, let's go and get my pen here. It's in red. Let's get it in black. This must have been 30 degrees or pi over 6. There we go. All right, so 30 degrees or pi over 6. And 45 would have been pi over 4. Okay, so there we go. All right, moving on. So when does sine give me out 1/2? Well, when I take 30 or pi over 6. So I come over here and I put 30 degrees in my triangle. Now I know you guys are used to going like this. And you're saying, okay, the answer is 330 degrees. And I get that and I respect that and you're right. But remember, when you're dealing with arc sine, your answer for theta is restricted between -90 and less than 90. Okay, so your answer must fall somewhere in here. So instead of putting 330, we're going to put -30. Okay, so theta equals -30 degrees. Well, Mr. Earhart, when do we do that? When do we have to worry about these two quadrant restrictions, whenever it's arcsine or arccosine or arctangent, that's when you have to worry about that, okay? All right, let's continue on. All right, let's go ahead and clear this off and try not to erase my table this time, and let's continue on, all right? Let's take a look at this one over here, all right? Here we go. Let's pick up the pace a little bit. Sine -1 of 2, which would be sine of theta equals 2. Okay, so we're trying to find an angle that when you take sine of that angle you get 2, and it should be undefined, should be no solution. Second sine of 2, yes, it's undefined, and that makes sense, students. If you think back to the sine graph, the original sine function graph, the highest that ever went was 1, and the lowest that ever went was -1. Okay, over and over and over. So you can never have sine of an angle giving you out something greater than 1 or less than -1. Okay, so if you'll type this in your calculator, you'll see there is no solution. So the answer would be no solution. Okay, let's go ahead and continue on. Here we go, picking up the pace a little faster now. Let's go. Here's this one. Grab this. All right, here we go. This would be tangent of theta equals -8.45. Now, again, tangent of theta, arctangent, you're restricted to this quadrant here or this one here, okay? So I'm going to go ahead and hit second tangent because notice I am looking for an angle, student. So second tangent of -8.45, and I'm going to get out -83 degrees. And that makes sense. Notice how your calculator automatically puts it in the fourth quadrant for you. Okay, it's programmed to do that, -83.2 degrees. Now why I put 84, I have no idea. I guess old age, but anyways, 83 degrees. So the answer would be -83 degrees. All right, moving on. And I know we spent a lot of time on this page, but if you'll notice on the screen there's only 10 pages. We're already on page 6, so we don't have that much to do, okay? We really don't. All right, arcsine of 0.2447. Let's rewrite that as sine theta equals 0.2447. So we're looking for sine. We're looking for an angle, so that when we take the sine of it, we get 0.2447. Now it's positive. So we know we're going to be in this quadrant here. There's no 0.2447 down here in the table, so I'm going to use my calculator. Second sine of 0.2447, enter, and I'm going to get 14.16 degrees. So I'm just going to go ahead and put 14 degrees, okay? There we go. Not too difficult. Moving on. And you're going to see once again, this is going to be undefined. Guys, look, watch this, please. I knew that right away, and here's why. Let's first of all rewrite this. Arc cosine of 2 means cosine theta. Cosine of theta equals 2. Remember your cosine graph? Your cosine graph never went higher or lower than 1 or -1. And so there's no angle you can take the cosine of that's going to give you out 2. Now go ahead and with your calculator, go ahead and try if you want to. So take your calculator and hit second cosine and then 2, and you're going to get undefined. So the answer is undefined or no solution. All right, and that's it. Let's move on to the next page. Now we're going to get into some really, really challenging, interesting stuff. So please, please pay attention, okay? Use an inverse trig function. Copy this down, please. Copy this sentence in your notes and copy this triangle in your notes, if you would, please. Use an inverse trig function to write theta as a function of x. Now let's pause, and you should know what this means, theta as a function of x, from Algebra 2, but just in case you're a little forgetful about that, let me refresh your memory. If I said this expression here, if I said y as a, if I can spell y as a function, and you don't need to write this down, just watch, y as a function of x, all that means is you want to get y by itself, and then the only variable you want over here is x. Now you might have some numbers and stuff like that. That's fine, something like 5x plus 3 or something like that. But y is all by itself, and the only variable over here is x. That's y as a function of x. So with that in mind, if I'm asking you to write theta as a function of x, that just means you want to have theta all by itself, and then the only unknown you want to have over here is x. Okay? Theta as a function of x. You want theta by itself, and then you want to have only the x variable on the other side of the equation. So it sounds pretty difficult to do, but if you think about this, it's not too difficult. First of all, notice we have a right triangle here they've given to us, and they're showing us which angle they're calling theta, which is this angle right here. And so based on this angle here, if I go straight across, this is my opposite side, and of course this side here is my adjacent side. So since the two sides they've given me are opposite and adjacent, I'm going to use tangent. So watch what I do here. See if this makes sense, students. Tangent of theta equals opposite over adjacent. Okay? Now, I want to rewrite it so theta is by itself. Now think about that for a second, students. Let's go backwards, okay? Remember, if I have arc tangent of 5, I'm just making that up. Does that not mean tangent of theta equals 5? Well, let's go backwards. If I have tangent of theta equals this, then I can write what? I can write arc tangent of what? X minus 1 over x squared minus 1. There we go. And that whole thing equals, even though we've never written it like this, students, think about it. This whole expression here equals theta, because look, listen to me, students, whenever you have arc tangent of, let's say, 5, what does that mean? That means tangent of theta equals 5. In other words, your unknown is theta. You're looking for an angle. Anytime it's arc tangent or arc sine or arc cosine, you know right away you're looking for an angle. So really you could say this equals theta. So look what I did. I took my regular tangent ratio, tangent of theta equals opposite over adjacent, and then I rewrote it with arc tangent, and when I did that, really this expression right here just equals 0. It's not theta, that's 0 right here. Okay? Now the only thing left to do is this. You're in the big leagues now, you're in pre-cal, and all of your answers, of course, are supposed to be simplified. So the only thing is we can simplify. This expression a little bit. The denominator here, x squared minus 1, can be factored. We know the square root of x squared, and we know the square root of 1, so the square root of x squared is x. So we'll put an x here and an x here. The square root of 1 is 1. Put a 1 here and 1 here. Make one positive. Make one negative. Now you see why we spent time on factoring the first week of class. When factoring comes up like this in a regular problem, we're just going to go through it quickly and move on, okay? So the numerator is x minus 1. The denominator is x plus 1, x minus 1. Well, this will cancel with this, leaving you with arctangent of 1 over x plus 1 equals theta. And then off to the side put as long as x does not equal negative 1. And it's important you state that, students, because look, if you put negative 1 in for x, your denominator would become a 0. Okay, and we can't do that. So this is the final answer. Now we'll do some of those in your homework, okay, so make sure you really understand this, and you'll get some chances to practice this in your homework, okay? All right, let's continue on to the next page. All right, here we go. Let's write this as an algebra expression in terms of x, okay? So we're going to write this as an algebra expression in terms of x. Now, first of all, let's start inside the parentheses, okay? Now watch this carefully. Arc cosine of 3x. Well, that means cosine of theta equals 3x, okay? Now, let's think about this for a second. Let's go ahead and get a picture of it. Cosine of theta equals 3x. Well, cosine is going to be here or here, And notice when you're taking cosine of theta, you're getting a positive 3x. So we're going to be in the first quadrant. So here's theta. Now watch carefully. Cosine of theta equals 3x over what? 1. So cosine is adjacent over hypotenuse. So the adjacent side is 3x, and the hypotenuse is 1. Now that I've got the triangle drawn, using Pythagorean's theorem very quickly here, one of my legs is 3x. Okay. My other leg, I don't know what it is, so I'm just going to call it y, I guess. So y squared equals hypotenuse squared. So I'm trying to find quickly this last side over here, students. Okay. So leg squared plus leg squared equals hypotenuse squared. 3x squared would be 9x squared plus y squared equals 1. 1 times 1 is 1. Now, bring the 9x squared over and make it negative, so y squared equals 1 minus 9x squared. And now take the square root of both sides, and the square root of y is y, and the square root of 1 minus 9x squared is 1 minus 9x squared. Now, a lot of students right here want to take the square root of the 1 and the square root of the 9 and the square root of the x squared. I'm sorry, I didn't mean to laugh, and put this. That's totally incorrect because you have two terms, okay, under the radical. Here's one term right here, and here's the other term. Whenever you have more than one term under a radical, you can't just take the square root of one term and the other term. That's completely incorrect. Okay, so there's really nothing simplification-wise that you can do with this expression. So this whole side over here is 1 minus 9x squared. Now, Mr. Earhart, why did you do all this? Because look, first of all, we took arc cosine, and we rewrote it as cosine theta equals 3x over 1. And we did that to get our triangle. And now that we have our triangle, remember, please don't miss this, students. Look, anytime you're solving an arc cosine, you're getting out of theta. You're getting out of angle, a theta. So this entire expression right here is theta, okay? Arc cosine of 3x means you're trying to find theta. So I wrote it like this. Cosine of theta equals 3x. And I drew my triangle here so I could see it. But now this whole parentheses right here really becomes theta. So I'm just left with, bring down your sign, I'm left with sine of theta. Let's go over that again, okay? Anytime you're given arc cosine or arc sine or arctangent, that means you're looking for an angle or you're solving for an angle. And so really when you're all done simplifying arc cosine, yes, the arc cosine helped us draw our triangle and get all the information over here, but in the end, when you're done simplifying an arc problem, you're going to be left over with an angle. And in this case, the angle was theta. So now we bring down our sine, we're going to find the sine of theta. And the sine of theta would be opposite over hypotenuse. So square root of 1 minus 9x squared over 1, which is really just the square root of 1 minus 9x squared. There we go. There's your answer. Look what you did. You took this and you wrote it as an algebra expression in terms of x. You did it. Now the only thing is, there's a couple of numbers here that x cannot be. And I don't think, students, I'm going to probably make you list out what x can or cannot be on this type of problem here. Now in the last problem, it was really obvious that x could not be -1 because -1 made your denominator become 0, okay? But on this problem here, this one's a little more in detail, and I will quickly show you what to do, but I don't think I'm going to make you do this on a test or a quiz. So first of all, let me say this. Your answer for this problem would be this right here. Okay, there we go. Now, having said that, there are some things that x cannot be. I'm going to quickly refresh your memory, hopefully from Algebra 2. Remember, you can never take the square root of a negative number. So what you do in these situations is you take the radicand, that's the number under the radical, and you quickly set it equal to 0. Bring the 1 over and make it a negative 1. Now divide both sides by negative 9. And a negative 1 divided by a negative 9 is a positive 1/9. Now take the square root of both sides and you'll get positive negative 1/3. Then on a number line you put 0, 1/3, negative 1/3. And again, I'm not going to make you do all this. I'm just trying to quickly refresh your memory, hopefully from Algebra 2. But you test numbers from each area. For example, you would take a number over here to the left of negative 1/3, let's say negative 1, and then you would take a number between negative 1/3 and 1/3, let's say 0, and then you would take a number to the right of 1/3, let's just say 1. It could be any number, but 1's an easy number, and you take each one of these numbers and you substitute them in up here, and you see if you get out a negative number, a negative radicand, or not. Like put a negative 1 in for x real quick. Negative 1 squared is 1, and 1 times 9 is negative 9, 1 minus 9 is negative 8. So when you put negative 1 into this expression, you get the square root of negative 8, and that's no good. So you know that none of the numbers from this area over here are going to work. Now, if you put a 0 in for x right here, you would get out, let's see, 0 times 9 is 0, 1 minus 0 is 1. You would get out the square root of 1, which is possible. So you know that all the numbers in this area work. And then you check 1 over here, and if you put 1 in for x, you're going to see that 1 does not work. You get out once again the square root of negative 8, okay, which is no good. So this area over here doesn't work. So if I was really trying to be super picky on you guys, I would say to you, this is your this is your answer here, but then also off to the side you have to put this: x is greater than or equal to negative 1/3 and less than or equal to 1/3. So if you see some expressions like that in the back of the book when you check your answers, I'm not going to make you put that, okay? But just so you know, that is how you would do all of that, okay? And this would be the answer right here. All right. Okay, moving on. Okay, let's look at some problems now that have a trig function and an inverse trig function combined in the same problem, okay? So here we go. Let's take a look at this problem right here. And here we go. Not too difficult. We have tangent of arctangent of -5. So bring down your tangent. Let's change colors here so you can see that a little better. Okay, bring down your tangent. And then inside I'm going to rewrite my arctangent, tangent of theta equals -5. Okay, there we go. Now, think about this for a second, students. Think about this. Whatever I take the tangent of, okay, I know I'm going to get -5, okay, the tangent of some angle. Now, I'm dealing with negative. That's going to put me over here in this quadrant right here. Remember, tangent is restricted to the first quadrant and the fourth, so tangent of theta equals a -5. So I'm going to come down to this quadrant here and put theta here, okay? And theta is -5, so opposite over adjacent. So there we go. And now this whole thing becomes theta. So really I'm taking the tangent of theta, and of course the tangent of theta would just be -5, okay? So you've really gone in a circle here if you think about it. You had arctangent of -5, which means tangent of an angle that gives you -5, and then whatever that angle is, take the tangent of it and you get out -5. So the answer would be -5 because you're taking the tangent of theta, and the tangent of theta would be opposite over adjacent, which is 5, and tangent in this quadrant is negative. Okay, now that won't, if you're thinking every time that you see tangent, arctangent, or sine and arcsine, or cosine and arccosine, you can just assume this is the answer. It's not always going to work, so please understand that. Okay, sometimes due to undefined and stuff like that, that won't always work. So the best thing to do is to work the problem out like we did here, and make sure you get the answer on your own. Okay? All right. Let's go ahead and continue on to the next problem here. Arc sine. Here we go. Okay. Now this one's a little different. Here, the arc functions on the outside, which is fine. We're going to start right here on the inside. Sine of 5 pi over 3. Now I think it'd be easier if the first thing we do is we change the 5 pi over 3 to degrees. It could help all of us. So we're going to get 300 degrees. Okay. So now we're going to find the sine of 300 degrees. Okay. So we bring down our arc sine, and we're going to find the sine of 300 degrees. So here we go. 300 degrees. We know how to do that. We go 300, and we're left over with 60. So really, instead of finding the sine of 300, we're going to find the sine of 60, as long as we remember that sine is negative in this quadrant. So I'm going to put a negative sign here. And now let's find the sine of 60. Remember, the sine of 60, students, is the exact same thing as the sine of 300, as long as you put a negative sign here. So sine of 60, let's go back up here. Sine of 60 is square root of 3 over 2. So I'm going to go ahead and put square root of 3 over 2, negative. So now I have arc sine of this right here. Well, arc sine of this just means sine of an angle, which equals negative square root of 3 over 2. Do you see that? And now I'm saying which angle, when I take the sine of it, will give me negative square root of 3 over 2. Well, I'll be in this quadrant here, of course. And look, go back to your chart. You've gone in circles again. I mean, we saw that the sine of 300 is this, which is the same thing as the sine of 60. And now we're taking the arc sine of this, which is what you got when you took the sine of 60. So if we look back here, it's the sine of 60 that gives you square root of 3 over 2, right? Sine of 60 gives you square root of 3 over 2. So with that in mind, then what would theta have to be? Well, theta would not be 60, students, okay? Not 60, because remember, we're trying to find an angle that gives us a negative square root of 3 over 2. We'd be in the fourth quadrant here, okay? I know you guys are used to starting here and going all the way around and putting 300, but hold it. We're dealing with arc sine. And arc sine, remember, your theta has to be greater than or equal to negative 90 and less than or equal to 90. So it's got to fall somewhere in here. Okay, so the answer would be negative 60. Negative 60. Okay, I hope that makes sense. All right, let's continue on. All right, let's try this one here. All right, now this one's going to be undefined. Let me show you why, okay? Okay, we start inside the parentheses here. So we bring down our cosine, and then we rewrite the inside of the parentheses, and we put cosine of theta equals pi. Now in this case here, pi is not an angle, so it's not radians, okay? So if it's not radians, it would be the same thing as putting 3.14. Well, with your calculators, if you go ahead and type in second cosine of 3.14, you're going to get undefined. Okay, it can't be done. So there is no cosine of this angle. Thus, you cannot take the cosine of what you would get out here, because there is no angle that when you take the cosine of that angle, you get 3.14. If you want to try that, you can. Go ahead and hit second cosine with your calculator, and then 3.14, and you will get undefined or error or no solution. Okay, all right, let's move on to the next problem here. Okay, here we go. Let's start inside the parentheses. So I'll bring down my tangent, and then arc cosine would be cosine of theta equals 2/3. Okay, so let's see here. We'd be in the first quadrant because 2/3 is positive. Here's theta, adjacent over hypotenuse. All right, and very quickly, using Pythagorean Theorem, we would get square root of 5 over here. Okay, so remember, whenever you take arc cosine or arc sine or arctangent, you're really getting out theta. So we've taken this, and it's helped us draw our triangle. And now this whole expression here is really just an angle. Bring down your tangent. So in the end, we're finding the tangent of theta. So the tangent of theta would be opposite over adjacent. So square root of 5 over 2. And we are in the first quadrant, so your answer would be positive. Okay? All right, one more of these, and then we'll move on to one more problem, and we'll be finished for the video. Okay? Here we go. Okay, let's start inside the parentheses. So bring down your cosine, or inside the brackets. So I'm going to put sine of theta equals negative 3/5. Okay, now what? This is a really interesting problem. So watch this. Okay, sine of theta equals negative 3/5. All right, so here we go. It's arc sine, so we're dealing with the first or fourth quadrant, and it's a negative 3/5, so we're going to be in the fourth quadrant. Okay, so here we go. Sine of theta was negative 3/5, so opposite over hypotenuse. If you quickly use Pythagorean Theorem, you will see 4 is your leg right here. Okay, and now all of this is really an angle, so it comes out to be theta. So we're taking the cosine of theta. Cosine of theta. Okay, well, the cosine of theta, first of all, cosine is positive here. Okay, so your answer will be positive. And the cosine of theta would be adjacent over hypotenuse, so the answer would be positive 4/5. Okay, there we go. All right, moving on to our last problem. This one's pretty tough, but we can do this if we take our time here and work this through. First of all, remember, arc cosine of this equals arctangent of this. Now, let's think this through for a second, okay? Remember, both of these arc expressions here are really just thetas, or an angle. For example, arc cosine of x minus 2 over 2 is the same thing as cosine of theta equals x minus 2 over 2. Now, let's go ahead and draw a triangle just to get a picture of this. It's a positive fraction, so we're in the first quadrant. So here's theta. And let me just pause and say this, students. All that I'm doing here is I'm just taking this left side and just kind of working with it a little bit, okay? Just kind of working with it and simplifying it and seeing what kind of information I can get from it. And so here's my triangle. Cosine is adjacent over hypotenuse. Now quickly, using Pythagorean's theorem, I'm going to find this missing leg right here, okay? So here we go. Leg squared, we'll just call it y. Leg squared plus leg squared equals hypotenuse squared. Now hopefully you remember from algebra 2, x minus 2 squared is not x squared plus 4. X minus 2 squared really means x minus 2 times x minus 2, okay? Which would be x squared minus 4x plus 4 equals 4. Now, remember, we called this side y right here. We're just trying to solve for that side. So we're trying to get y by itself. So I'm going to bring all of these terms over to the other side and change their signs so that y squared is all by itself. Okay, so here we go. If I do that correctly, I'm left with y squared equals negative x squared, positive 4x, negative 4, positive 4. Okay, so I brought this term over, changed the sign. I brought this term over, changed the sign. I brought this term over and changed the sign. Now, notice I have two like terms here, positive 4 and negative 4, so I'm going to go ahead and delete those. And now take the square root of both sides. So the square root of y is y, and the square root of negative x squared plus 4x is, you don't have to do this. I'm going to go ahead and put the 4x first. So 4x minus x squared, and you don't have to do that. So there we go. We found what the side is. It's this right here. Okay, let me erase all this work here. And there we go. Now students, think about this. Please watch this. Watch this carefully, okay? See if this makes sense. What I'm looking to do is I'm looking to put something in this blank right here so that this whole side here equals this whole side here. Now think about that. Let me say this to you. This whole side here ends up being theta. And if I put the right expression in over here, this whole side here will end up being the exact same theta. Well, students, would I not just use opposite over adjacent down here? Think about it for a second. Watch this. I'm going to go ahead and put opposite, tangent, opposite over adjacent. So I'm going to put this 4x minus x squared all over x minus 2. Now watch what happens. This is perfect. Watch this, okay? Now, using this expression right here, if I said what angle, when you take the cosine of it, gives you x minus 2 over 2, it would be this angle here because adjacent over hypotenuse, so it would be theta. And if I said what angle, when you take the tangent of it, gives you the square root of 4x minus x squared all over x minus 2, it would be theta because here's your opposite side and here's your adjacent side. So we end up with theta equals theta when we put this into the parentheses. Okay, now these are not easy. A lot of these problems that we've gone over today are not easy, but they're really, really good thinking problems, students. Really good, okay? And tomorrow, I know it's, well, I'm going to give you a good amount of homework, but in the homework tomorrow, you're going to practice problems like all the problems we've done, plus problems like this. So it'll be really good practice for you, okay? All right. I hope this video has been a help to you. If you need to rewatch it again tonight, feel free to do that, of course. And make sure that you're caught up on your notes, all right?